Hi everyone, welcome back to Math with Amala. Let's start a new part of your chapter. Number 5 of grade 8 Squares and Square Roots. In this chapter, we are dealing with the squares and their reverse or inverse procedure, the square root. Squaring means actually we can compare it with the area of a square of side A, one side A measure, then A into A is equal to A square. Some examples are given for the squares of numbers starting from 1 to 10. They are 1, 4, 9, 16, 25, 36, 49, 64, 81 and 100. If a number m which is natural can be expressed as n square, where n is also a natural number, then m is a square number, then n square is called the perfect square. Let's move to the properties of square numbers. Numbers ending in 1 will have squares ending in 1 only, and this is happening for the numbers ending in 9 also. Then the squares will end in 1. For the numbers ending in 6, then squares will end in 6, and for 2 it will end in 2. When in 3 it is 3. Likewise you can continue and go through the table. Some more interesting patterns. We are having some patterns which deals with the squared numbers. We can add the triangular numbers. What are triangular numbers means? They are the numbers which can be represented in the form of a triangle, like the numbers 1, 3, 6, 10, 15 which are represented here. While combining two consecutive triangular numbers, you are getting a square number. 1 plus 3 equal to 4, 3 plus 6 equal to 9, 6 plus 10 equal to 16 and 10 plus 15 equal to 25. Second pattern, numbers between square numbers. There are two non-perfect numbers between the squares of the numbers n and n plus 1. When n is equal to 5 and n plus 1 equal to 6, you can have the squares like 25 and 36, and in between you will have 10 numbers which is actually 2 into the first number, 2n, that is 2n. Third pattern, adding odd numbers. Sum of first n odd numbers is n square, or if the number is a perfect square, it has to be the sum of successive odd numbers starting from 1. For example, 1 is equal to 1 square itself, but 1 plus 3, the odd number addition will give you 4, that is 2 square. 1 plus 3 equal to 9 will give you 3 square. 1 plus 3 plus 5 plus 7 is equal to 16, that is 4 square. 1 plus 3 plus 5 plus 7 plus 9 is equal to 25, that is 5 square. If a natural number cannot be expressed as a sum of successive odd natural numbers starting with 1, then it is not a perfect square. Fourth pattern, a sum of consecutive natural numbers. Perfect square n square can be expressed as a sum of consecutive natural numbers. That is, n square can be written like n square minus 1 by 2 plus n square plus 1 by 2. Then in example you can see 3 square is equal to 3 square minus 1 by 2, 3 square plus 1 by 2. 9 minus 1 by 2 plus 9 plus 1 by 2. Answer 8 by 2 plus 10 by 2, that is 4 plus 5, 9. That means 3 square is 9 itself. Fifth pattern, product of two consecutive even or odd numbers. If we consider in the case of odd naturals, a plus 1 into a minus 1 is equal to a square minus 1 square. Let a equal to 10. Then 13 into 11 is equal to 143. That is 12 square minus 1. Here 10 is a and a plus 1 is 13, a minus 1 is 11. The numbers which are just before and just after that. Now we're multiplying 13 into 11. The answer is 143, which is actually 12 square minus 1, which is the number in between this 11 and 13. Next topic, finding the square of a number. Identities can be used to find this without actual multiplication. Like 39 square can be written like 30 plus 9 the whole square, which we have done already in the identity part. Now let's come to the Pythagorean triplets. The numbers which satisfy the Pythagoras theorem are called Pythagorean triplets, like a square plus b square is equal to c square. A, b, c are Pythagorean triplets. You can have the examples like 6, 8 and 10. And also in general for m greater than 0, 2m square plus 2m the whole square plus m square minus 1 the whole square is equal to m square plus 1 the whole square. We can find a Pythagorean triplet in which one number is 12. You can give the m square minus 1 as 12, then m square is 13, then m is not an integer. That means we are not getting a perfect or square root, it is not possible there because root 13 is not an integer. So take m square plus 1 equal to 12. In this case also we are not getting it properly. M square is 11. M is not an integer. Now we can take 2m is equal to 12. Then m is equal to 6. Here we got an integer. And you can check it out again. Here we are correctly getting the numbers 35 and 37. That means the triplets are 12, 35, 37. And you have to note that it is not always true. Because for the triplet like 5, 12 and 13, it is not true. The next thing is square roots. Finding the number with the non-square is known as finding the square root. 1 square equal to 1, here the square root of 1 is 1 itself. 2 square equal to 4 means the square root of 4 is 2 and minus 2 because 2 square and minus 2 the whole square are 4. There are two integral square roots of a perfect square number, positive and negative, like 2 and minus 2. Positive square roots are denoted by the simple root, that is the root, and that root 81 is equal to 9 or minus 9, root 64 is equal to 8 or minus 8. Now while finding the square root through repeated subtraction, you can get the square root actually here. Through repeated subtraction, 81 minus 1 is equal to 80, 80 minus 3 equal to 77, 77 minus 5 equal to 72. Likewise, you can continue till 17 and then 17 minus 17 is equal to 0. That means root of 9, 81 is equal to, root of 81 is equal to 9. That is 9 times we have repeatedly done the subtraction. What is the idea behind this? We have a result that when we add the successive odd numbers, you are getting a perfect square. Likewise, it continues here also. The last topic, finding square root through prime factorization. Let's take a number 324 and you can do the prime factorization like this by taking the least possible prime from it. Then 2 is the least possible prime. Then you can take 2, then you will get 162, then 2 again, 81, 3, 27, 3, 9, 3, 3. So the answer is 2 into 2 into 3 into 3 into 3 into 3. Like 2 is multiplied 2 times, that is 2 square. 3 is multiplied 2 times in 2 ways, that is 3 square into 3 square, that is 2 into 3 into 3, the whole square. Hence, the reason for not writing 3 raised to 4 and writing 3 raised to 2 is just to take the whole square and in the root form. Here the answer is root of 2 into 3 into 3 the whole square. Here the root and square will be getting cancelled. That's equal to 2 into 3 into 3, that is 18. Likewise, you can find the square root of 6400. Keep practicing and don't forget to follow this channel for more updates. Thank you all for watching the video. Please stay tuned for the upcoming parts of your classes.